nucleophilic substitution reactions in haloalkanes and haloarenes. They are represented as SN reactions. There are two types, that is nucleophilic and substitution. Two types of SN reactions, SN1 and SN2. Let us take this as the alkyl halide RX plus a nucleophile. A nucleophile may be having negative charge or it is having lone pairs of electrons. What happens is that the halogen, being more electronegative, will attract the bonded pairs of electrons towards itself, and the halogen will get removed as the halide ion, and in its place the nucleophile will come and get attached. So as a result you will have a product like plus X minus of halogen as the halide ion. So since the nucleophile is substituting the halogen, it is called a nucleophilic substitution reaction. Now here, in the case of a methyl halide, so we'll take H. You have a nucleophile approaching it and it is attacking the methyl halide, and as a result you are getting a product like this, where the chlorine or the halogen is still attached to the carbon and the attacking nucleophile is also just attacking or just getting attached, and the chlorine or the halogen is just leaving. So such an unstable intermediate, this is in between. Unstable because here we can see that carbon is attached to 1, 2, 3, 4, 5 groups. Now a carbon cannot extend its valency beyond 4 because it doesn't have d orbitals. So this is unstable, and this is an intermediate, something formed in between, and this is called the transition state because it is getting changed. It is getting changed because this halogen will leave as the halide ion and the nucleophile will be attached to the carbon. So the product you are getting will be like now the halide ion is gone and you have the nucleophile attached at this site. So the nucleophilic substitution has taken place. Here we can see that with respect to the reactant which you started with, the position of the hydrogens are exactly opposite to where they were in the beginning. So this is an inverted product, and only one type of product is formed. This is an inverted product because the nucleophile attacked, or the nucleophile got attached to the carbon from the opposite side of the leaving group. The leaving group is this halogen. So the attacking nucleophile came in a direction opposite to that of the leaving nucleophile. Leaving nucleophile is the halogen. So you have got a single product that is an inverted product, and you call it Walden inversion. Now here you can see that this is a bimolecular reaction. That is, two molecules are getting involved here. One is the nucleophile and the other is the alkyl halide. So you call it a bimolecular reaction. Since two molecules are involved in this step, this is the only step in this reaction. So this is also the rate determining step. Now, since two molecules are taking part in this reaction, or two molecules are involved, you call it a bimolecular reaction, and this follows second order kinetics. Now that is why we call this SN2 reaction. That is because it is taking place in one step, but it is a bimolecular reaction. Now you can see here that the nucleophile is making its attack from the back, or the halogen is leaving from front and the nucleophile is getting attached at the back. Now just imagine if you were having, now we took a methyl halide, but if you had R or alkyl groups attached here to each carbon, to this carbon, you can see that there will be one hydrogen, hydrogen here, hydrogen here. And if you are having another R group here and another R here, you can see that these are huge, or these are bulkier groups, isn't it? As a whole, the CH3 will be a big group, and the nucleophile will not be able to get attached here, or it will be very difficult for it to make this attachment here, or this attack at this site. So the reactivity of the alkyl halide will depend on whether it is a methyl or a primary, secondary or tertiary alkyl halide. So since if bulky groups are attached to this, it will be very difficult for the nucleophile to make this attack at this site. So there will be steric hindrance. That is, due to the spatial arrangement of bulky groups around this central carbon, the nucleophile will not be able to come and attack at this site because of steric hindrance. So if there is more steric hindrance, the reaction will be very, very slow, or not even possible at times. Now why can't the nucleophile come and attack from the front where the halogen is leaving? Both are nucleophiles. They are having electrons, and because of the electron repulsion, that is not possible. That is why the nucleophile will come and attack from back, and that is why you are getting a single product, and that will be inverted. So reactivity we are talking about SN2 reactions. Reactivity of alkyl halides in SN2 reactions will be methyl more reactive than primary, which will be more reactive than secondary, and which in turn will be more reactive than tertiary. So this is for SN2 reactions. Reactivity will be in this order: methyl greater than primary, greater than secondary, greater than tertiary. Whereas in the case of SN1 reactions, you know that in SN1 reactions it happens in two steps. First one is the formation of a carbocation. So the more stable the carbocation, the more faster SN1 reaction takes place. So if it is a tertiary carbocation, it will be very stable. So reactivity in SN1 reactions will be like this for alkyl halides. Tertiary greater than secondary, greater than primary, greater than methyl. So that will be the order of SN1 reactivity in alkyl halides. Whereas for SN2, the order of reactivity will be like this. So we said that SN2 reactions are bimolecular reactions following second order kinetics. Then in the rate determining step, or this reaction takes place in a single step, there are two activities going on, that is leaving of the halogen and the attack of the nucleophile. Both are taking place, but as a single step it is taking place, or it is taking place simultaneously. So that is what we are seeing here. And the nucleophile will attack only from the back, or the direction opposite to that of the leaving halogen. So the product, or you will be getting an intermediate product. It will be unstable, and we call it the transition state, which we show by putting in square brackets like this. So this is the transition state. Now from the transition state you get the product, which will be a single product, an inverted product, and you call it Walden inversion. Whereas in SN1 you got two products because of the shape of that carbocation. The planar geometry of the carbocation made it possible for the nucleophile to attack from both sides. So this was the carbocation you got in SN1. So nucleophile could attack from here, or it could attack from here, and you got two products. One was an inverted product and the other was the retented product. But in SN1, SN2, you are getting only a single product, that will be inverted product. And the reactivity will depend on steric hindrance and the concentration of the two reactants, nucleophile and the alkyl halide. And the bulkier the groups are, the more difficult the reaction will be to take place.